All right. So, word problem. On the word problem, we're going to go through and we're going to go through our solving for the word problem or critical response technique. And the first thing we do is identify the question. The question is a portion of the last sentence. And the last sentence says, how far did each drive? And so from there, we're going to start identifying the different pieces. So, how far is going to identify our action of numbers. And so how far is going to be either going to be addition or subtraction, whether it gives us a total and we take away to figure out what's left of how much, or we're going to take some and add them together and we're going to get a total. And so therefore that gives us our action of numbers. And the drive knows it's going to be a distance. How far is going to be measured in a distance. So that helps me identify my units. Okay? So from there, let's now go and circle the numbers. And this one's got something I want to talk about in it. So here is a 3, here is a 5, here is an 85, and do y'all see any more? See any more numbers in the problem? Okay, good. That's what I want to get to. We sometimes are not going to identify the worded numbers. Okay, so the worded numbers are important as well. So twice represents 2 times, right? Represents 2 times. So that's also something that helps us out. So look for the worded numbers as well. All right? And so what we took out of there is we had 85, 5, 3, and the word twice. That were the numbers that we identified. All right, so we had 85 miles. Okay, 85 miles. We had 5 miles. And we had 3 times. Okay, so we know that's going to be multiplication because it didn't have units with it. Okay, and we know that twice is going to be multiplication as well because once again it doesn't have units with it. All right, and so now that we've gone through there and we've identified all that stuff, there are portions of the passage we're going to have to see and know. And what we do know is that the very first, we know we got 3 things, right? We got 3 people, okay? And we know that the 85 miles is the total distance, correct? It's the total distance. And so since it's the total distance, I know that, and I can use the letters that Sue, Juanita, and Kim drove a combination of 85 miles. Right? Do we agree with that? So all of them drove that total. And so now we're using a sentence here of Juanita because as we're looking at these numbers here, it identifies things from here that we're needing to know. And it says that Juanita drove 5 miles less than 3 times as far as Sue. Okay? And so we're going to go off of Juanita. Juanita equals what? She drove 3 times as far, or 5 times less, or 5 miles less than 3 times as far as Sue. All right? And so that would be 3 times Sue minus 5 would equal Juanita's driving distance. Okay? And then the last one says Kim drives twice as far as Juanita. All right, and so Kim is going to equal 2 times Juanita. And there are our 3 equations. We have this equation here. We have this equation here. And we have this equation here. Now, this problem is very similar to the one with the swim meet stuff that people took numbers and they checked them out. Okay? And they guessed and checked to find the answer. Anybody do the same thing with this one? Or did everybody try to create equations now that we have done a problem where we did equations? Okay? I never want to hurt your logical thinking and make you go, oh, I got to do equations because we did equations in that one problem. If you can do it logically thinking and it doesn't say, hey, list the equations or identify the equations that represent the system, then don't worry about that. Use your logical thinking to answer the question. And what the question says is, how far did each drive? So when we get done, we're going to need to know how far Sue, Kim, and Juanita all drove. That's the main point of the whole thing. Okay? And so what we got to do now is we got to get these in standard form so we can plug them into our matrix. Okay? Do we have to use matrices here? We don't have to. We got some things here that we could actually use some substitution with, don't we? We got some things we could use substitution. We got a variable by itself. We got some coefficients of 1. We can use some substitution if we wanted to. Okay, I'm going to use matrices so it helps us to continue to stay constant with some of you that have been using them, but we don't have to. Okay? So, this one's already in standard form, so it's good. We can go ahead and plug it into matrix form if we need to. This one needs to change around. So what do we got to do to get this one into matrix form, or get this one into standard form? What needs to move? The 3s, right? And so that's going to become negative 3s plus j, because it's positive, equals negative 5. Okay? What about this one down here?
May I have your attention, please? Second breakfast in the gym will begin between 1st and 2nd today, and there's a crew meeting at this time in the library.
All right. And so what do we do right here? What needs to move? Either one of them needs to. So what I would do is I would look at that and see the order in which my variables are in. And I probably wouldn't try to make my leading one negative. That doesn't always work, so I'm just going to move the 2j over so I know what's going on there. So I have negative 2j plus k equal to 0. So those are my 3 equations, and this is what my matrix would look like. My matrix would be 1, 1, 1 times, my variables are s, j, and k, and this one, the solution of the first one is 85. Okay? Now I'll go into the next one, this one right here. There are some variables missing, are there not? If they're missing, how do I represent those in my matrix? Good, with a 0. Okay? And so it's in the form of s, j, and k, and so this is going to be negative 3, 1, 0, and negative 5. And then this one's going to go in as 0, negative 2, 1, and 0. So my augmented matrix is going to be 1, 1, 1, 85, negative 3, 1, 0, negative 5, and 0, negative 2, 1, and 0 is going to be my augmented matrix. Okay? So I'm going to enter that one in. Second. Three by 4, 1, 1, 1, 85, negative 3, 1, 0, negative 5, 0, negative 2, 1, 0. I'm going to row reduce it. And there we have it. Comes out to be 10, 25, and 50. Now what you need to know right here is which order you wrote the variables in. Okay? Because it doesn't say that I have to go in this order. That's just how the sentence started right up here at the top in the order S, J, and K. I can put it in whatever order I want. You just got to know that these got to line up accordingly. It doesn't change the value, it just changes the order of your solutions.